Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to look at section 2.2, which is all about the first and the second derivative rules. Now, the first derivative rule, what this says is if you plug any value into the first derivative and you end up with a value greater than 0, meaning it's positive, then you can say that the function is increasing at that point. So visually, let's say I have a point and I fill this in right here, okay? If I go ahead and draw a tangent line, my tangent line has a positive slope. So what that means is at this point, my original function is increasing. So visually, that's what that means. In order to see if a function would have a tangent line that has a positive slope, you would take the first derivative, fill in the x value. If it's bigger than 0, that's what it means. If you have a first derivative and you fill in an x value, whatever value you're looking at on that graph, and you end up with a negative, something less than 0, you might have a scenario like this. When you draw that tangent line, notice that the slope is negative. That means that the graph is decreasing. Okay, so what you're thinking of is the direction of the tangent line. Are your y values increasing or are your y values decreasing? The way that you can tell is using the first derivative. So in other words, a function is increasing whenever the value of its derivative is positive. A function is decreasing whenever the value of its derivative is negative. The image of the first derivative rule is shown below. So again, just kind of like I showed you, think about that tangent line. If you were to draw a tangent line, if it has a positive slope, it's increasing. If you draw that tangent line at that point, if that tangent line would have a negative slope, you can say that the function is decreasing. Okay, so again, everything's kind of all related, which is awesome. Here's what the book is going to have you do. Now, there's probably a lot of different solutions that would work for this, okay? So what you want to do is take the information that they're giving you and you need to sketch a function that has those properties. So you just go one step at a time and take the information we know and figure out what it would look like. This is f of x equals 4. So remember, because of the notation f of x, whatever value's in the parentheses, that's your x value. So f of 3 equals 4 really means we have the ordered pair 3, 4. So I go to the right, 1, 2, 3, go up 1, 2, 3, 4. That's the ordered pair. That's what that means. Okay, now the first derivative. Okay, the first derivative is greater than 0 for any x's that are less than 3. So that means to the left, I'm going to draw something where if I drew tangent lines, they would have a positive slope because it has to be increasing. Now, when you have a first derivative that equals 0, that means that you have a maximum or a minimum point. So at 3, we have a slope of 0. So that means it's a maximum or a minimum. Got that? Any x value that's greater than 3, your first derivative is less than 0. So that means that it would have to be decreasing. So if I drew tangent lines from any of those points, you would have a slope that's negative. Okay, now here's the big thing where I said it could be different. You could have this as wide or as narrow as you drew it. Okay, all we know is that we have to have the ordered pair 3, 4. We know that as you're going from left to right up to the point they gave us, it has to be increasing. At that point, that is a maximum or a minimum. In our case, it's a maximum. To the right of that, it would be decreasing. So that's all that you have to do there, okay? Second derivative rule. Second derivative rule is all about concave up and concave down. Concave up means if you have a line, your curve is up above the line. Concave down means that if you have a line, your curve is down below the line. So concave up, the curve is up. Concave down, the curve is down. Concavity is based off of the second derivative. So if you take the second derivative, plug in a value, and you get a positive, it's greater than 0, then it's concave up. If you have the second derivative, you plug in a value and it's negative, then it's concave down. So positive values, concave up. Negative values, concave down. If you have a second derivative and it equals 0, okay, it doesn't give us any information. So typically what this means, this is an inflection point, because the rule says if it's greater than 0, it's concave up. If it's less than 0, it's concave down. So what happens if it equals 0? They didn't tell us that. 9 times out of 10, it's going to be an inflection point, okay? Same thing here. When you're looking at your first derivative test, if it's greater than 0, it's increasing. If it's less than 0, it's decreasing. Well, what happens if it's 0? That's where we have extreme points, maximums and minimums. Okay, sorry, I somehow skipped that. All right, let's move on. So here is an image of the second derivative rule, and it's really cool to kind of look at the relationships that happen. Notice that this whole thing is concave down, okay? The curve is down under the line. The curve is down under the line. The curve is down under the line. When you have something that is concave down, notice that the slope decreases. Here I have a pretty steep positive slope. This is still positive, but not as steep. This would be 0. So as you have a graph that's concave down, going left to right, your slope is decreasing. Well, what happens if I have a slope or a curve that's concave up? Because there'd be the tangent line, there'd be the tangent line, there'd be the tangent line. Here the slope is negative, here it's 0, here it's positive. So when you have it where it's all concave up, notice that the slope increases left to right. And these are just little relationships that we will notice as we work through sections 2.2, 2.3, and 2.4. It's just really helping us tie all those different ideas together. Now there's a table in your book on page 144. I think it's super, super helpful. So I did include it in the notes. It's on the back side of your notes. It's just showing you how things can be increasing and concave up, or they can be increasing and concave down. You could have something that's decreasing and it could still either be concave up or concave down. Those of you who are visual learners, you can see exactly what that point would look like. If I'm looking at A, if I draw a tangent line, it has a positive slope. So the first derivative would be positive because it's increasing. The slope is positive. If I had the second derivative, it would be positive because it's concave up. The curve is up above the line. If I had A right here, this is positive first derivative because it's increasing, positive slope, but the second derivative would have a negative value because it's concave down. The curve is down below the line. If you have a negative slope, here, this would have a negative first derivative because your tangent line has a negative slope, so it's decreasing, but you would have a positive second derivative because it's concave up. That curve is up on top of that tangent line. Here, if I had a tangent line on A, this is negative for both first and second derivative because it's decreasing and it's concave down. So to me, this is really, really going to help just give you a visual as we're going through some examples. Now, here's what the book questions are going to be like. And again, you just got to go one step at a time and ask yourself, okay, what would that look like? Okay. Here, they straight up just gave you ordered pairs. So I need a point at 1, 2, 1, 2, 3, 2, 3. I need a point at 1, 2, 3, 4, up, 1, 2, 3, 4, 5. There's a point. I need a point at 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, so that's step 1. And I know you guys have that. You can plot points. Now here, if you have a first derivative equal to 0, those are your maximums and minimums. At that point, your slope is 0. So where x is 6, 1, 2, 3, 4, 5, 6, your slope at that point is 0, meaning it's a horizontal line. At x equals 2, remember that's the value that's in the parentheses. If I go to the right 2, the slope is 0. So that is what I know from that. So those would be my maximum and minimum points. Now here's our second derivative test. So this is concave up, concave down. So here it's saying anything that's less than 4. 1, 2, 3, 4. So on this side, your second derivative is positive. So it's concave up. If it's concave up, that means you're looking at a parabola or a curve that's going upwards because it's above all of the tangent lines. The second derivative at 4 is 0. So that's an inflection point. So what that means is if you try to draw a tangent line, it would end up being vertical. You don't know if it's concave up or concave down. Here, second derivative is negative. It's less than 0 when you have values that are greater than 4. If it's concave down, your curve or your parabola is opening down, because now if I do those tangent lines, the curve would now be below. You could stop right there. If you were like, hey, I'm going to extend this and draw arrows, perfect. You're fine. The main thing is I'd have to be able to look at your assignment and say, do you have a point at 2, 3? Do you have a point at 4, 5? Do you have a point at 6, 7? Those would all be worth a point. Do you show that you have a maximum or a minimum where x is 6 and x is 2? The way that you show that is you draw a little horizontal slope. So we know that those are your maximums and minimums. If you go to the left, are all of these values concave up? Well, heck yeah, they are, because your parabola opens up. If we are going ahead and going greater than 4, so going to the right, is everything concave down? Yep. And notice that the parabola, if I picture it as a parabola, it's opening down for concave down. Okay, again, a lot of this is connections. So remember when you're looking at f of x, x is a location on the x-axis. How far are you going left or right? Y is the height on the y-axis. Are you going up or down? Your first derivative, you still have x. The x is the same. As you go to the left or the right on the x-axis, the y value, however, is the slope. Because remember, the first derivative is the formula to find the slope. So you fill in the x value, which just means that you're traveling to the left or the right, but what it kicks out, that y value, is the slope. So just kind of showing you visually what this looks like. This is awesome. So here's a graph of 8x minus x squared. Okay, notice it is a parabola because it has a degree of 2. It's negative in front of your squared term, so it's opening downwards. Here at 1, the slope is a 6. Here the slope is a 4. The slope is a 0. The slope is negative 4. The slope is negative 6. This is all concave down. Because this is all concave down, what they were able to do is go ahead and say, okay, 1, the slope is 6. 2, the slope is 4. 4, the slope is 0. So they graphed it, and you could see that because this is all concave down, the slope is always decreasing. So again, just making those connections. So what they did is they graphed this. They used the x value because the x stays the same, but now they graphed the y to see if there was a pattern. You guys, that's the main idea for 2.2, is just really getting used to some of those different ways that they're talking about things. What does the first derivative really tell us? What does the second derivative really tell us? If you're given information about a graph, could you provide a general sketch of what this thing might look like? So you're going to go ahead, if you're working towards the extra credit on your next test, the book questions that I feel would really help you with this are 1 through 15. Jump ahead, do 19, 24, and then 43. You can find them in your textbook on pages 147 to 150. Hope you guys had a great time today looking at 2.2, and I'll talk to you soon.